Today, I'll show you how the Bering Strait Bridge is being built, connecting the United States and Russia for the first time.
The logistics here are harder than building on the moon. If the heating fails, everything freezes in minutes. These modular camps are the lifeline for the thousands of engineers, including many African-American men living on the frozen sea. Before we build up, we must look down. The seabed here is uncharted and unstable. We are using sonic drills to map the bedrock beneath the silt, finding stable anchor points. Every weld must be perfect. In these temperatures, steel becomes brittle and can shatter like glass. We brought the factories to the street. These barges would produce the concrete need for the foundations. This isn't normal steel. It's a special cryogenic alloy designed not to crack when the temperature drops. We thicken the ice artificially to support trucks carrying hundreds of tons of materials. This island in the middle will serve as the central anchor point for the bridge. We are carving a flat staging area right into the granite of the island. The Arctic Titan crane arrives. It can lift 5,000 tons, crucial for the next phase. The rigging alone takes days to set up in the biting wind. The view from up here is incredible, but one wrong move with the wind could be catastrophic. The work never stops. During the winter darkness, the strait is lit by artificial suns. Weather is our biggest enemy. When wild hits, all theory work must be in place. The ice seat is alive. We constantly monitor stress fractures to prevent the cane from being swapped. Maintenance is strenuous. Hydraulic fluid turns to jelly if the heating elements fail. Keeping this channel open requires the icebreakers to run back and forth continuously. The templates for the foundations are ready. Now begins the most dangerous part of the build.
This is one of the most ambitious infrastructure projects ever imagined.
We are about to sink the first foundation. It has to land perfectly 50 meters down in the dark. The crane takes the strain. 5,000 tons of steel hang suspended over the water. It begins its descent to the seafloor, guided by sonar and underwater robots. Touchdown. The first prone and structure of the Bering Strait breaks in place. A moment of relief. The foundation is perfectly lined with the GPS coordinates. With the template set, we are ready to begin pouring the actual foundations of the bridge. We drive these steel piles 30 meters into the solid rock beneath the seafloor for stability. The force required to drive these piles shakes the ice for miles around. We use a special underwater concrete mix that cures even in near-freezing water temperatures. The concrete displaces the water, creating a solid rock anchor fused to the seabed. This concrete heats up as it dries. We have to cool it so it doesn't crack in the freezing water. The first pier breaks the surface. Now we must armor it against the winter ice pack. The piers are shaped like knife blade to slice through moving ice flows that hit them. This design reflects the crushing force of the eye, forcing it up and around the structure. We add armor plating to the concrete. The ice here is hard enough to grind away bare cement. One by one, the foundations rise, a stepping stone pass across the gap between continents. Now we begin the vertical climb. We slip-form construction to build the massive towers. The concrete must be kept warm all the way up the tower or it will freeze inside the pumps. The forms rise inches per hour, 24 hours a day, leaving finished concrete behind them. We are now 100 meters up. The wind chill here makes it feel like -70. As we go higher, the weather gets worse. The towers must withstand hurricane-force Arctic winds. Every movement is difficult. The crews work in short shifts to prevent frostbite. The heat generated by the curing concrete creates plumes of steam visible for miles. 200 meters, we install the cross bracing to stabilize the tower legs. The connections must be incredibly strong to handle the twisting forces of the wind. The first main tower is topped out, a colossal structure standing defiant in the frozen waste. I'm standing on top of the world. From here, I can see Russia on one side and America on the other. This saddle will hold the weight of the main suspension cables, the backbone of the bridge. On the Siberian side, Russian engineering teams are mirroring our progress perfectly. This is a unified effort. International cooperation is essential for a project this scale. The central tower on the Diamond Island is shown half-built on the rock. This central anchorage will be the strongest point of the entire bridge. We are tying the bridge directly into the core of the island. The towers are designed to flex in these storms, swaying meters without breaking. Thousands of sensors monitor the health of the structure in real time, feeding data to control centers. Giants are in place. The vertical phase is complete. Now we must connect them. The towers are done. Now comes the hardest part, spinning the cables across this windy gap. The first connection is made by a drone carrying a thin pilot wire across the span. This single wire is the guide that will eventually pull the massive main cables across. The spinning wheel travels back and forth thousands of times, laying individual steel wires. Each pass adds more strength. It takes months to spin a single main cable. Courageous ironworkers bundle the wires into the final cylinder crochet, hundreds of meters up. The finished cable contains tens of thousands of wires, strong enough to hold an aircraft carrier. We compress the cable to ensure it acts as a single solid steel unit. This cable is the lifeline of the bridge. It feels incredibly solid, like a steel artery. Next, we hang the vertical suspender ropes that will hold the road deck itself. The web of steel is complete. The silhouette of the breach now dominates the Arctic Rhine. The road deck is too complex to build up here. It arrives in massive pre-built steel sections. We prepare for the heavy lift. Each deck section weighs over 1,000 tons. The lift is slow and calculated. Any swinging motion due to wind must be immediately stopped. It's a delicate ballet of heavy engineering, fighting gravity and the Arctic elements. Once at height, ironworkers are ready to grab the section and secure it to the hangars. The initial connections are made. The first piece of the road is officially hanging over the strait. I'm standing on the first piece of the road. It's floating 300 meters above the ice. Section by section, we lift them into place, like building a massive puzzle in the sky. The alignment must be millimeter perfect before they are permanently welded together. We use automated welders to ensure flawless, uniform joints between the massive sections. The deck grows outwards from the towers, slowly closing the gap over the open water. The final piece, the golden cement that will physically connect the two continents. For the first time in history, you can walk from North America to Asia. I just stepped from the USA into Russia without getting on a plane or a boat. This is history. The span is complete, but we cannot drive cars on an open deck in these winds. The bridge must be enclosed in an aerodynamic tube to protect vehicles from the extreme weather. We install steel ribs over the deck, forming the skeleton of the protective tunnel. The enclosure is made of triple-layered heated glass designed to withstand impacts and extreme cold. The heating elements inside the glass prevent ice and snow from blocking the incredible view. Inside here, it's calm. The glass blocks the wind, making it safe for cars to drive at high speeds. The gleaming glass tube now runs the entire 55-mile length of the crossing. The scale of the interior is immense. It is ready for the final infrastructure to be installed. Crews lay a specialized asphalt mix designed for durability and high-speed travel. Road markings are applied, 2 lanes in each direction plus emergency shores. Thousands of LED lights will illuminate the tunnel, turning night into day for drivers.
And this is how the impossible becomes reality, the bridge connecting the USA and Russia.
Giant ventilation systems are installed to cycle fresh air and remove vehicle exhaust. This is the brain of the bridge. We monitor wind, temperature, and structural integrity every second. Safety is paramount. The tunnel has state-of-the-art fire detection and suppression systems. Final inspections begin. Every inch of the structure is scrutinized before open to the public. We conduct extreme load tests, driving massive weight convoys across to prove its strength. The aerodynamic shape works perfectly, allowing Arctic winds to flow smoothly around the structure. Below the car deck, we are also installing high-speed rail links for future cargo and passenger trains. The rail link will revolutionize global shipping, connecting Europe and Asia by train. The toll plaza is ready. This is the gateway to the longest drive bridge on Earth. The signage goes up, a surreal sight on the edge of the Arctic wilderness. The construction dust is cleared away. The bridge is gleaming and ready for the world. We clean up our footprint. The tempering ice cants are moot, leaving only the bridge behind. The icebreakers salute the finished structure. Their job here is done. The impossible project is finished, a stunning ribbon of human ingenuity across the frozen sea.